So good afternoon, all of you, and let's start today's class. So in the last class, we have finished, I think, till validity of ray optics and wave optics. Yes or no? Yes, validity of ray optics and wave optics. Now today, we will see what is wavefront, then types of wavefront, and if possible, Hygienes Principle also we will see in today's class. So let's start from wavefront. Okay, try to understand this carefully. Means listen particularly. Wavefront. What is this wavefront? Okay. So see here, wavefront means what? Actually, the locus of all the particles. What is that? See here, the locus of all the particles vibrating in the same phase, vibrating in the same phase, that is called wavefront. So see, for example, yes, Aditya. The locus of all the particles vibrating in the same phase means, suppose now here you are having light source and this is what the light is emitting. Yes, something like this. The light is emitting from this point. So what I will take one set of points, okay, which are in the same phase. So this is what we can say set of points, right? Can you see? So at each and every point, the particle is vibrating in the same phase. Understand? So this is what your wavefront. Understand? Any doubt? Please ask. Yes, clear? Yes, no, understood? Yes, right. So how the direction of the light taking place, that is, we can say direction of motion of light. Wavefront you understood, right? Now see here, direction of motion of light. I will show below with diagram also. So direction of motion, of the light is normal to the wavefront. Is how? Normal to the wavefront. Okay, right. Yes. Now let's see types of wavefronts, and then you will understand how this light is propagating normal to the wavefront. So see here, I'm showing you one diagram. Suppose now here is a point source. Okay, this is a point source. Now from this point source, light will travel in all possible directions. Yes, no? Light will travel in all possible directions. Right? Something like this. And now if I am taking at this point or at this distance, this set of all the points, you see here these particles I am taking, which are vibrating with the same phase. Yes. Then this set of points is called what? Wavefront. What is this? Called as a wavefront. Yes, no? And you see here, this arrow is how perpendicular. Hai na? Arrow is how perpendicular. You see. So this is what the propagation of light. Understand? Perpendicular to the wavefront. Understand? Any doubt? You see how light is propagating perpendicular to this wavefront. Clear? Yes. So direction of motion, this also you understood, and how it is perpendicular to the wavefront, that also I have shown you in the diagram. Okay, right. Now, so how one can decide the shape of wavefront? What is my question? Listen carefully. How one can decide the shape of wavefront? So see, shall I write one line like this, that shape of wavefront, shape of wavefront depends on shape of light source, shape of light source from which it is originating, है ना? Right? For example, some time before I have shown you spherical wavefront. Yes. Then suppose cylindrical wavefront we are having, that is linear source. If suppose plane wavefront we are having, then what type of source will be? That we will see in the types of wavefronts, right? So next one, that is types of wavefronts. Let's see how many types are there. Types of wavefront. Right. So first I am taking, that is spherical. First one is what? Spherical wavefront. So how is the shape of this? Shape of the light source, shape of light source is point source. Okay, this spherical wavefront we are getting from the point source. Okay, spherical wavefront from point source. So let's see the diagram. You see here, suppose now here I am having the point source, and now I am taking, these are the wavefronts we can say, which I have selected. And let us suppose this is what the light which is passing in all possible directions from this point. Okay. Yes, right? Now see here, in this case, how amplitude varies. Amplitude varies with distance. Amplitude varies with distance. That is, A is diagonal proportional to 1 by D, or even we can say this A is inverse proportional to R. That is, as you are increasing the distance from the source, your amplitude will be decreasing. As R increases, A decreases. Vice versa, inversely proportional. And you know, in the wave chapter, you have learned that is intensity is directly proportional to amplitude square, and therefore intensity I is directly proportional to 1 by D square, or you can say I is inverse proportional to 1 by R square. Clear? Understood? Yes? Clear? Any doubt you can ask, right? Okay. This is what about the spherical wavefront. So what we have learned, see, a spherical wavefront is obtained from point source. Amplitude varies with distance, that is inverse proportional. As you are increasing the distance, amplitude will decrease. And if you want to find intensity, then intensity is directly proportional to amplitude square. And therefore, I is inverse proportional to D square, or I is inverse proportional to R square. Yes, understood? Yes, clear. Shall I go to the next page? Yes, good. Okay. Okay, Deepak. Note down. Right. Shall I go to the next page? Yes. Okay. Right. So see now, the next type of wavefront, that is what? Cylindrical. What is that? Cylindrical. Now this cylindrical wavefront means this is because of what type of source? Linear source. Linear or slit. Yesterday I told you one experiment, that is by taking two blades. So by attaching that two blades at the sharp edges, we are getting one fine slit. Like that, source will give you cylindrical wavefront. What it will give? Cylindrical wavefront. So let's see how it is. Its shape. So see here, this is what the linear source we can say, like a tube light. Okay, linear source, or you can say this is a slit from which we are getting some light. Okay, this is what? Linear source. And now at each point around this equidistance, we can say You see here how we are drawing Gaussian surface. Gaussian surface, you know, in electrostatics. Yes, like that, you are getting like this cylindrical shape around this linear source of light. Okay, something like this. Yes, this is what cylindrical wavefront. So from this source, the light will get distributed something like this. You see here. I'm showing with the diagram. Try to understand. You see this light will get distributed in all possible directions. Similarly from here also. Yes, something like this. Something like this. Yes, just draw the diagram. Yes, finished. Understood? No, how? Here also, okay, around this tube, you assume that this is a tube, okay, and like this around it everywhere you see like this around this tube, and this is nothing but one cylinder. Getting my point? Understanding? Yes, something like this around this tube we can say. So this is what one cylindrical shape of the wavefront. Is that clear? Understanding? Yes? Yes, no? Right. Okay. Now, in this case, the amplitude is directly proportional. So amplitude varies with distance as A is inverse proportional to root D due to the cylindrical shape, or you can say A is inverse proportional to 1 by inverse proportional to root R, or directly proportional to 1 by root R. And as you know, again, intensity is how ray intensity is directly proportional to amplitude square. Yes, no? So here if I want intensity, what I should get? Intensity I is dial proportional to A square, and therefore intensity I is dial proportional to 1 by D, or in this case I is dial proportional to 1 by R. Okay, where in case of cylindrical wavefront. Okay, right? How it is? Cylindrical wavefront. Yes, finished? Okay. Shall I move ahead? Okay, right. Okay. Now next one is the plane wavefront. What is next one is? Plane wavefront. So see here, this is third type we can say, and that is plane wavefront. है ना? So how it is, or who will provide plane wavefront? Who will provide plane wavefront? For example, we have learned tube light or point source. Yes, no. Point source will give you spherical wavefront. Linear source or slit will give you cylindrical wavefront. Now, who will give you plane wavefront? So, see, the extended source we can say which is at infinity. For example, sun. Sun is at large distance from us, right? So it will give you plane wavefront. So see here what I am writing. Extended large source. Extended large source situated at very large distance. For example, shall I write sun? Yes. For example, what? Sun. Let us suppose sun. Now, how is the plane wavefront? You see here, I am drawing the diagram. Now, these all rays are coming. Okay. Right. So see, this is what the plane wavefront which I am drawing. You can draw with me. Yes, it is very easy. So something like this. like this. Yes, no. This is what the plane wavefront. You see, this is from where it is originating, from the sun, we can say, because sun is a extended source which is very large distance, which is at very large distance, we can say. So this is from sun. Okay, like this wavefronts. And if you will see at each and every point here, the amplitude is not varying at all. Is amplitude varying here? No, amplitude is not varying. So in this case, amplitude is constant. Amplitude is constant. If amplitude is constant, will intensity change? No. Why? Because intensity is proportional to amplitude square. If amplitude is only not changing, why intensity will change? And therefore, intensity also constant. Intensity is also constant. है ना? So see here, what we have learned? Point source spherical wavefront. Point source spherical wavefront. How amplitude varies? Inverse proportional to D, inverse proportional to R, and intensity is inverse proportional to R square. Next, linear source, that is linear or cylindrical wavefront, linear source we can say. So amplitude is inverse proportional to root D or root R, and intensity is proportional to R. And for the plane wavefront, extended large source which is at infinity, and here amplitude and intensity is constant. Understand? Is that clear? Yes, understood? No? Clear? Okay, right. So let's see what is the hygienes principle. Yes, what is the hygienes principle? Good, Ishan. Right. So next one is hygienes principle. What he is saying, you see. So first point is what in this, you see. Each point on the given or primary wavefront, each point on the given or primary wavefront acts as a source of secondary wavelets. Secondary wavelets. Sending out disturbances in all possible directions, in a similar manner, as the original source of light does. As the original source of light does. Ha. So listen, I will tell you one example. Suppose there is a man, okay, old man, and now his business, what we can say, let us suppose he is a painter, okay, painter, and now his son is also following him, and he is also doing a painting. Understand? Means what? This is a secondary source, suppose, and this is a primary source or primary, whatever it is, wavelet we can say, or wavefront. So this secondary or whatever the points are there on that wavelet, they will also do the same work as the first one was doing or original source was doing. So here you see with diagram I will tell, if you did not understand this also. See here, this is a source now, okay, and it is sending light in all possible directions. Okay, right, understood. Okay, now I have taken, this is my wavefront, okay, this is what my wavefront now. Now I am selecting this point, this point, this point, this point, this point. So these points are also again sending the light in all possible directions, same like this source only. Means in general language we can say that all the points on the wavefront will behave as a secondary source of light. Okay, what I said, listen carefully. All the points on the locus will behave as a secondary source of light, and they will emit the light in the same direction as the source is sending. Understood? Is that clear? Yes, any doubt, please ask. Understand? Yes? Clear? Okay. Yes? So see, this is a light source, okay, and whatever this wavefront I have taken, all these points are also behaving as a secondary source of light and emitting the light in the same direction as the source provides. Understand? Means in short language we can say the point on the locus will behave as a secondary source of light. Yes, understood. Please tell me. Clear? Right. Yes. Now, second point, you see, second point of this Hygienes principle, the new position, the new position of the wavefront at any instant called secondary wavefront, means from that secondary source of light, whatever we are getting another wavefront, is the envelope of the secondary wavelets of the secondary wavelets at that instant. Okay, at that instant. This is what your Hygienes principle. Okay, clear, understood? Means suppose now I have taken here this point source, which is on the already on the wavefront, we can say. This is actual wavefront, right? This is a source and I have taken this point. So around this point, whatever I am taking now, again another wavefront. Suppose this is another wavefront, we can say like this. Then this is the envelope of the secondary wavelets at that instant we can see. Okay. This is what Hygienes principle. Okay. Yes. Here I will tell you this in tomorrow's class with diagram, how the plane wavefront and the, what you can say, spherical wave and their first initial wavefront, and then what you can say later time how it is the next wavefront is getting formed with diagram, that we will learn in tomorrow's class. So today what you do, you just revise this and just read carefully whatever we have finished. This is just a basic part we have started. So that's why I'm going little slow. Then in between, when our real chapter will start, real in the sense this is also real only, but when mathematical expressions or something like that will start, that time we will go in deep. Okay, so that it will help you in understanding, right? Okay, so let's stop here for today. Bye, enjoy the day.
Bye.